Welcome to Center of Math's Unusual Properties in Math series. Today we're going to give two examples, one of a function that is nowhere monotonic on its domain, a function from reals to reals, and a function who is continuous and one-to-one on an interval and whose inverse is not continuous. So an example of a one-to-one correspondence between intervals, which is nowhere monotonic. So we're going to take f of x equals x if x is rational, and 1 minus x if x is irrational. So this is a one-to-one correspondence that's nowhere monotonic from 0, 1 to 0, 1. Note it's nowhere monotonic because the rationals and irrationals are both dense in the closed interval 0, 1. So any neighbor of any point, we always have points above and below in any direction. So it's nowhere monotonic. This is one-to-one, since f of x equals x. If x is irrational, x is also irrational. F of x equals 1 minus x. If x is irrational, 1 minus x is also irrational. If you take any x in the image, or say y in the image, f of x equals y. If y is irrational, then x equals 1 minus y gives us the unique x in our domain to give us y. If y is rational, then just take x equals y. And so this is, in fact, a one-to-one correspondence. And it's nowhere monotonic. So a function that is continuous and one-to-one on an interval whose inverse is not continuous. So we're going to take f of x. This is going to be from reals to real squared. F of x equals cosine x comma sine x. So f is from the interval 0 comma 2 pi. Contains 0, doesn't contain 2 pi, to the unit circle in r squared. So first, this is clearly one-to-one. It just gives you each point in the unit circle exactly one time, and it's also continuous. Take any point here, take a small enough neighborhood, the neighborhood in the circle also gets arbitrarily small. But note the inverse function cannot be continuous. If the inverse function was continuous, that would imply, since this unit circle is compact, it would imply this interval is compact, which is not true. And also you can look at the point 1, 0 to see, take the inverse function around 1, 0. No matter how small we take it, we're always going to get points on the left and right side of this interval, and so it's not continuous at 1, 0. So that's another example. Thanks for watching. Please check out centermath.org, check out our blog, and follow us on Facebook and Twitter. And if you like this video, please check out our other unusual properties and math videos in our playlist. Thank you.